Previously, we showed that if you have the limit as x goes to a of the quotient of two functions, f of x and g of x, and if both of these functions evaluated at a give you 0, then you can say that this equals the limit as x goes to a of the quotient of these two functions' derivatives, provided that this limit exists. But we didn't consider is that what happens if instead of x going to some value a, what if x is going to positive or negative infinity? So that is what we are going to look at now. So we have the functions f of x and g of x, and we're told that as x goes to infinity, f of x and g of x approach 0. So we would like to show that the limit as x goes to infinity of f of x over g of x equals the limit as x goes to infinity of the quotient of their derivatives, provided that this limit exists. So let's look at the limit as x goes to infinity of f of x over g of x. So I don't know how to handle x going to infinity, but if x were going to some value, like 0, then I could handle it nicely. So I'm going to make a substitution. I'm going to let u equal 1 over x, and while I'm at it, let me do the reciprocal on both sides, so x will be 1 over u. And I'm going to now rewrite this limit in terms of u, because this is the limit. If x is going to infinity, and u is 1 over x, as x goes to infinity, u will be approaching 0 from the right. And we have f of x, which is 1 over u, over g of x, which is also 1 over u. And as u is approaching 0 from the right, of course, the insides of these functions are approaching positive infinity, and we know that as that happens, the function values will be approaching 0. So we can use what we proved previously, and that is that when we have the limit as a variable goes to 0 of the quotient of two functions, and that if both of these functions evaluated at 0 give you 0, we can just take the derivative on the top and the bottom. So we'll do d dx on the top and d dx on the bottom. And we'll say that this equals the limit as u goes to 0 from the right of, well, if we differentiate f of 1 over u, we'll get f prime of the same input, 1 over u. But then we have to use the chain rule. So we'll look at the inside function here, 1 over u, and multiply by the derivative of that. The derivative of 1 over u is negative 1 over u squared. And then on the bottom, we basically get the same thing, but with g. So the derivative of g of 1 over u is going to be g of, well, actually, it'll be g prime of 1 over u times the derivative of the inside function. So we'll multiply by negative 1 over u squared. And as you can see, the negative 1 over u squared cancel out. And now we are basically done, except I'm just going to put this back in terms of x. So I'll say this is the limit. And if u is going to 0 from the right, if x is 1 over u, we know that x will be going towards positive infinity. So x is going to positive infinity. We have f prime of 1 over u, which is our x, over g prime of 1 over u, which is also our x. So we've shown that this equals this, which is what we wanted to prove. And now I'm going to look at when we have x approaching negative infinity instead. So this time we basically have the same thing as last time, but this time as x is approaching negative infinity, f of x and g of x are approaching 0. So again, I'm going to take a look at the limit as x goes to negative infinity of f of x over g of x. And I will do a substitution, but this time, since x is going to negative infinity, I'm going to let u equal negative 1 over x. And I will multiply both sides by negative 1 and do the reciprocal on both sides, so we know that x is just negative 1 over u. And I will rewrite this limit in terms of u. So we have the limit as u goes to what? Well, if x is going to negative infinity, if u were 1 over x, u would be going to 0 from the left, but since u is negative 1 over x, u will be going to 0 from the right. And we'll have f of x, which is negative 1 over u, over g of x, which is also negative 1 over u. And as u is going to 0 from the right, the insides of these functions are both approaching negative infinity. And we know that as that's happening, their values are approaching 0. And we already know how to deal with that. We can just differentiate the top and the bottom. So let's see what we get here. This is the limit as u goes to 0 from the right. The derivative of f of negative 1 over u is going to give us f prime of negative 1 over u, but multiplying by the derivative of the inside function for the chain rule, we'll multiply by 1 over u squared. And on the bottom, we will have g prime of negative 1 over u times 1 over u squared. And as before, these cancel out. And now I will just put this back in terms of x. So this is the limit. Well, as u goes to 0 from the right, if x is negative 1 over u, x will be approaching negative infinity. And this is f prime of negative 1 over u, which is our x, over g prime of negative 1 over u, which is also our x. So we've shown that this equals this, which is what we wanted to prove.